absolute value functions. Our objective here, we want to define and solve absolute value functions. So what do we know? Well, we know what absolute value is. Absolute value is the distance a number is from 0 on the number line. Absolute value is distance. And because it indicates distance, it's always positive. No such thing as negative distance. With the exception of 0, which is always 0 from 0 on the number line, there are always two numbers that are the same distance from 0. For example, both -2 and 2 are 2 units from 0. Absolute value is indicated by parallel bars. Examples of that include the absolute value of 3, the absolute value of a variable like x, the absolute value of an algebraic expression like x minus 2. Okay. Absolute value equation or function is any function of the form f of x is equal to the absolute value of x. Okay. Solving an absolute value equation requires recognizing what we pointed out, what we spoke to up here. There are always going to be two answers, because with the exception of 0, which is one number out of an infinite number, you're always going to get two answers. So we want to recognize there are always two possible solutions, one of which is positive and one of which is negative. Okay, as we solve these things, that's what we're recognizing. That can be summed up here. The absolute value of x equals a is equivalent to x is equal to a positive or x is equal to a negative of a in this case. So let's solve these things and take a look at them graphically. Solve the absolute value of 2x minus 3 equals 11. Well, there's nothing else stopping us here. There's no squaring, there's no multiplier. So we're just going to apply this. The absolute value of x equals a is equivalent to two equations, x equals a and x equals negative a. So we have 2x minus 3 is equal to 11. That's our positive solution. Or 2x minus 3 is equal to negative 11. That's our negative solution. Let's do the math. We'll add 3 to both sides. 2x is equal to 14. We'll divide both sides by 2. And in our first equation, x is equal to 7. Our second equation, we'll again add 3 to both sides. Negative 11 plus 3 is negative 8. And then we'll again divide both sides by 2. And x is equal to negative 4. So that's how you solve algebraic equations. You get that's how you solve absolute value equations. You get the absolute value by itself, and then you recognize that one solution will be positive and one solution will be negative. Let's graph it. So I'll write this down here graphically, and we'll do what we always do. Okay, we'll do the left side. So we'll do a y equals the left side, 2x minus 3. And we'll do a y equals the right side, which in this case is y equals 11. And we're looking for the intersection or intersections, because as we can see, we're going to have two intersections here, or we hope we will, because there are always two possibilities. Let's go to Desmos. Give me a moment. I need to turn it on. There we go. All right, let's get it where it's in landscape mode for you. All right, I think we're there. That should be pretty good, I think. Okay, so here, left side, absolute value key is right down here, absolute value of A above the ABC. So we have, in our first equation, we're going to have y, I think I got this straight. It looks like it's pretty straight. Y is equal to the absolute value, and there are the bars, 2x minus 3. You may recall from previous math classes, absolute value always graphs as a V, and there's an example of that right there. The right side is 11, so how about y equals 11? And then we're going to look for the intersection places. Well, my absolute value graphed in black, so there's the absolute value. My horizontal line graphed in red, there's y equals 11. Where do they intersect? Well, there's 1. We got the answer of -4 algebraically. Over here is the other intersection, and we got the answer of 7 algebraically. So there you have it, solving an absolute value equation. Let's do one more that has a little bit more going on, and pardon me for I lost track of my notes. So just give me half a minute here to get the paper I need. Sorry about that. I had turned the paper to look at something else before I started recording. So I goofed there on you. Sorry about that. Okay. Here is our second example. Solve 5 times the absolute value of 1 minus 4x minus 15 equals 0. Okay, so 5 times the absolute value of 1 minus 4x minus 15 equals 0. We need to get the absolute value by itself before we can apply write it as 2 equations. So let's first add 15 to both sides to get that 15 moved over to the right out of the way. So 5 times the absolute value of 1 minus 4x is equal to 15. Now we can divide, of course that's a 0, that's how that got taken away. Now we can divide both sides by 5, and that's a 1. So we have the absolute value of 1 minus 4x is equal to 3. And now that we have the absolute value isolated, we can rewrite it with one positive answer and one negative answer. So 1 minus 4x is equal to 3, or 1 minus 4x is equal to -3. And we'll solve these individually. Let's see, I think in this case, well, I'm going to subtract 1 from both sides. So -4x is equal to 2, I believe. Yeah, subtract 1, divide both sides by -4, and x equals -1/2. And for this one, again, I'll subtract 1 from both sides. I have a -4x on the left. -3 minus 1 is also -4. I'll divide both sides by -4, and x is equal to +1. I think the 2 answers that make this true are -1/2 and +1. Let's take a look at this graphically. As always, we're going to do a y equals left side and a y equals right side. So y is equal to 5, absolute value, 1 minus 4x, close absolute value minus 15, and y equals 0, which is the x-axis. And we are again looking for the intersection. And I'll put an S on here because absolute value is a V, I often will have 2 intersection points, 2 answers. And so let's take a look. So put this back up here and get myself lined up, or so I hope. I think we're good there. Let's cross those 2 out. Okay, my first equation, my first y equals equation is the left side. Y equals 5 times the absolute value of 1 minus 4x. Close absolute value, and then minus 15. I just close the absolute value by just pressing the right arrow key to move over to the right. I don't see another way to do that. So I just pressed the arrow key and it just bolded that for me, or it went from a shadow to a strong there. There we go. So if I kind of go in like this, you can see the V shape. There you go. There's the V shape. Okay, my right side is 0. So I'll put in y equals 0. So y equals 0. In this case, it's a green line. And of course, that's on the x-axis. You can see the y equals 0 right here. and it does indeed intersect in two places. Let's touch the first one on the left, and there's my -1/2, which is what I got algebraically. And then let's touch the second intersection on the right, and there's my x equals 1, which is also what I got algebraically. So there you have it, working with working with absolute value functions or equations.